Trent, here today. Hamlet. Trent 3. Hamlet, you're here, right? Hamlet, are you there, Hamlet? All right. So while we use differentiation, give you a little idea. You all know about gradients, right? How a line, right? So a straight line has a nice constant gradient. So for example, if you pick any 2 points on this line and find the gradient, right? And find the gradient, you're going to get one value, right? And the gradient is important because it tells you how the y and x related. So if I give you any two quantities like studying and playing game, right? And I want to see how they're related. One of the ways that you check and see how they're related is what you call gradient. Okay. So gradient is an important concept. All right. So the problem now is that not everything is a straight line. Sometimes, for those who remember, things look like this. Right? It's a curve. So it always changes. So at this point here, the gradient might look like that. At this point here, the gradient might look like that. So at each one of the points, it slopes differently. So we need a way to help us get a gradient. And that's where differentiation comes in. Differentiation allows us to see how these things change it. All right. So we're going to take a look at how to differentiate. All right. So if we have, let's say we have something like this. Let's say we have y is equal to ax to the power of n, right? Then the differential of y, and it's written like this, dy dx. It means to differentiate in y with respect to x, right? How do we differentiate? Well, bring it to the power, bring it down. Then write back e, and then you see the x minus 1 from that power. That's it, right? That's the steps to differentiate it. Bring down the n, whatever the power is. Whatever the power is, you bring it down, you write back whatever a is, and then you minus 1 from the power. Right? So what you see? dy dx. You bring down the 2, you write back the 5, and then minus 1 from the power. So that's 10x to the power of 1. That's it. You just differentiate that. That's it for differentiation. Bring down the power and you minus it 1. That's it. So if we had to do this here, what do you think the answer will be? What would the answer be for this one? 3. Next 3. That would be 3 minus 1. Right? So the answer is 9x. That's it. Right? That's the way you differentiate. Okay? Of course, it wouldn't be that simple all the time, but yes, that's the way you differentiate. They just make it look a little more complicated. I'll show you. You gotta do a few. So some topics that you will see in our math real easy, some straightforward, some a little more challenging. This is one of the easier ones. So you know when you finish, I'm gonna make you watch that video, right? Full differentiation. Some topics you wouldn't catch for the other. Like last time. For me, or you? I want you to one time average on this one, but you go differentiate one or two. Now alone. And that's the you go we get polar differentiation. Okay, the differentiation, I can do integration. That's two big topics now. The whole section now. Sometimes I'm doing section a lot of take care of. You can might come by your Friday or something. I like this word you go right. She'll get a rest and I will take it in the evening. And I decided policy. That will differentiate, right? Right, Avani, so to differentiate, bring down the power, write back the old value, minus 1 from the x. Right, that's the way we differentiate. Let's reach back as it. Hamlet. Oh, now we're gonna mess with mommy then. All right, good. So that's number 1. That's number 2. I wanted to try these 2 for me. Y is equal to 7x cubed. Y is equal to, let me change up a little bit, 5x. And then I want to see what you will do here. Y is equal to 2. Try those F now. 3, 4, and 5. Let's see what you come up with. That's not gonna work, right? 3 and 4, okay? 3 and 4, okay? So I figure out what 5 is. Right? Try something, give me a minute. A minute to win it all. We'll see what you come up with, right? Right? I just want to see online, just message what you all got for number 5. I just want to see what y'all come with for number 5. Want to see? Again. About number 4. Trigger. But 5 and 5 is. See how much we give. One minus 1. Right? That's 1 and 1. All right. All right, so let's see. So I want to see the mistake that we made, right? So dy dx, everybody got this one right because this one nice, right? You bring down the 3, you're right back to 7, and then you're minus 1 from the power. So this is 21x squared. Everybody get that one right? Very good. Here now, here's what we have to remember. 5x means 5x to the power of 1. So you're bringing the 1 in front, right? Right, the back the 5 and minus in 1 from 1. 1 minus 1 is how much? 0. So this is 5x to the power of 0. Anything to the power of 0 is, if you're not sure, check the calculator. 5 to the 0, 6 to the 0, 7 to the 0. Anything to the power of 0 is what? Check it fast online. Anything to the power of 0 is what? 1. Very good, Brandon. Anything to the power of 0 is 1. Okay? Anything to the power of 0 is 1. Right. So this will be 1 by 5. This will be 1 by 5, which is 5. Right? Now, what we're going to do? Now, I want you to use this here to figure out that. Same rules apply. You need to use this, what we learned here, and anything to the power of 0 is 1. See if we can use that to figure out what that answer is. Let's see if anybody got it online. Wait, Brandon got it. Brandon got number 5. That was the answer for number 5, Brandon. Well, what is sent there? That was the answer. Yeah, okay, very good. Avani, message what you think number 5 is. Hamlet. So what we're going on with your computer. I'm gonna message Trent and see if he can help you out. Yeah, what y'all come up with? Huh? 0. Yeah, 0 is the answer. Watch why. You all see anything here? There's no x here, right? So it's like saying 1, but we know that 1 is x to the power 0. Correct? 1 is really x to the power 0. So if I use this steps here to find dy dx, bring down this 0, right back the 2, 0 minus 1. It don't matter what you have here, this will just be 0. Okay? So in short, what we learn in short, number 1, if you were to differentiate ax, you will get a. Like how we differentiate 5x plus 5. And number 2, if you differentiate any constant, you will get 0. That's it. That's the way you differentiate. Now we can put it all together. Let's see if we can differentiate number 6. Put it all together. 7x squared minus 2x plus 3. Message your answers online. Abani, you too. Right, message your answer. Right? Message your answer for number 6. You're doing it all together. So you differentiate in this and this and this. All right? Message your answers online. And the extra 4. Differentiate 0. You know, there's no way, just right zero. That's right zero. You know, do all that options. I'm just showing you way to. Right, let me see what we have here. Correct, Brandon. Hamlet, send your answer, please. Avani, send your answer, please. Fix it? Fix it. So we can do it all together. And we'll get dy dx's, bring down the 2. Right back is 7 minus 1 from the 2. The differential of minus 2x is minus 2. That's it. We don't have to work it out. Just write the answer. Differential of 3 is 0. So your final answer for dy dx is 14x minus 2. Then we do shorter one. Yeah, do the shorter one. Right? Remember, the differential of this is 0. And the differential of minus 2x is just minus 2. All right, let's go again. Let's get the hang of it. Try that there. Try number 7, and I want to know what you'll do with number 8. Try number 7 and 8. Let's see how it right now. All right, so this one here is what? What you all got here? 45x squared minus 4x plus 5. Yeah?
Yeah.
How you all handle this? You all multiply it out? Yeah. If you expand it out, that's before you differentiate it. Before you differentiate it, you'll get 4x squared minus 4x plus 1. That's when you expand this out properly. Right? That's if you do that. 2x minus 1, 2x minus 1, 2x by 2x, and so on. If you do it properly, that's what you'll get. And then you differentiate it. So this will be 8x minus 4. Okay? So you'll get 8x minus 4. Yeah? All good, all good. All right, nice. So I want to show you a different way to do that. Right? What you would have done if it was to the power of 5. Okay, what you would have done if it was to the power of 3. Keep expanding it out. Yeah? If it's to the power of 4. So how long it will get? It will be a little bit harder. So there's a rule. There's a shortcut that you could use. There's a shortcut and a long cut. I will show you the shortcut first. All right. So it's a shortcut to differentiate things like this. Y is equal to ax plus b to the power of n. Very similar to what you do all the time. So the shortcut is this. Bring down the power. Right? Differentiate inside the bracket. Differential of ax is a, differential of b is 0. Then write back the brackets ax plus b and minus 1 from the power. That's a shortcut. Bring down the power. Differentiate inside the bracket. Write back the bracket minus 1 from the power. For example, if I give you y is equal to 5x plus 2 all to the power of 4. Watch it, Karen. Right? You bring down the power, which is 4. You differentiate 5x plus 2, which is 5. You write back 5x plus 2. And then minus 1 from the power. Okay? So you bring down the power, you differentiate inside the bracket, you put back the bracket, and you minus 1 from the power. So the answer is 20 by 5x plus 2 cubed. Okay? So we're done, and I want to just give you the steps here, right? So we're just done, and I want to give you these steps so you remember what to do. Copy down and just leave out a little spot for the steps, right? 4 steps. Very short step. Right? Ready for the 4 steps? Step number 1, bring down the power. That's right here, right? Just write down the 4 steps, right? Bring down the power. Bring down the power. Number 2, differentiate inside the bracket. Number 2, differentiate inside the bracket. Differentiate inside the bracket. Number 3, write back the bracket. Number 3, write back the bracket. Number 3, write back the bracket. And number 4, minus 1 from the power. Number 4, minus 1 from the power. Okay, so those are the 4 steps in the shortcut method. And copy down number 1. Copy down number 1, and then I'll give you 2 question answers. Try this here. 2 more. Try number 2 and number 3. Follow all the steps, right? Now somebody stole the pencil I stole. I know I'm there. Finish? Online, you'll finish it. Hamlet, Akoy, Avani, you'll finish it. 2 and 3. Hamlet. Let's check it out. So dy dx, you bring down the power, which is 3, right? You differentiate 2x minus 1, you'll get differential of 2x is 2, differential of minus 1 is 0. Right? Then you write back the brackets and you minus 1 for the power. Yeah? So we'll get 6 by 2x minus 1 squared. Yeah? Nice, and you can leave it just like that. This one here, dy dx, you break down the 4. The differential of 1 is 0. The differential of minus 2x is minus 2. Okay? Then you put back the bracket and you minus 1 for the power. So you're going to get minus 8 by 1 minus 2x. Right? You got the minus sign, right? So those are the little things that you will see in odd maths, right? Instead of giving you something straightforward like this, they'll switch around the signs here. Right? Instead of giving you a nice easy power, they'll give you a hard power. Right? For example, number 4. Right? So that's all odd maths is. Let's take this here and just change it up slightly. So instead of giving it like this, here's how it is given in odd maths. Sometimes, and not all the time. Sometimes they'll give it like this. What you do there? See, all the time it's looking nice and easy, and it just bring this for you. Okay, yeah. What you do? Leave it out. Yeah. We'll leave out that. But if it can't leave it out, what else it can do? Anybody remember what square root means when we did surds? Square root means to what power? Check back fast now. When we did surds, right? Instead of writing square root, we could have write to the power of how much? Anybody remember online? Square root means to the power of. Good job, Brandon. No, what does square root mean? To the power of what? So instead of me writing square root, I could write to the power of something. Brandon got it. Aha. Aha. Can you differentiate that now? Yeah. So that's basically what odd math is. Take the question slightly one step backwards, make it a little bit harder. But all you have to learn to do is how you take what they gave you and to put it in a form that you're familiar with. Because you can differentiate, but this looking hard, you never do one like this before. So you have to figure out how you're taking it from here to here. That's our maths. How to take what they give you and put it in a form that you're familiar with. That's all. That's all you have to learn to do in our maths. Right? Take the information they give you and put it into a form that you're familiar with. Hopefully you're familiar with it. Right? Hopefully you're revising your work and you're familiar with how to differentiate. But everything in ADMAS is that. Right? Take the question, put it in a familiar form, work it out. Okay? That's the key. We have to learn to put it in that familiar form. Right? Do that familiar? Right? So basically what you have there, the introduction and the differentiation. I didn't put any tricks on it. So let's go like tricks. I'll keep this there happening. Okay. No tricks. So you'll see when we're doing tricks, I'll spend the most amount of time on that topic. As normally do tricks during actually I'm doing tricks with my form body form 5s now. I do that for the whole holidays, I just do tricks alone. And we'll go this one. I work out this one, and that's it for your introduction to differentiation. Tuesday we'll do introduction to integration. And next Thursday is probability. All right, let's see what you got. Are we done? So you'll end up with divide the x's, bring down the power, differentiate in the bracket, put back the bracket, -1 from the power. A half by 2, that's 1. 1 plus 2x to the minus a half. You'll get that? Here's the hard value. You're not allowed to leave anything. See how you have a half here? You gotta put it back with the square root. All right, so copy now. So the rule is, and you'll learn this later on in indices, this negative sign means 1/. So every time you see a negative sign, it means 1/. It means division, right? Right? So if I take this division, if I take this negative sign off, I'll put the division sign in. Right? And then you could write it like this. Right, so here's what add muscle once again. They want to put it back in the same form, square root form. Okay. All right. So your thing is you need to make sure you're good at this. And then as you learn more advanced, you'll be able to go from here to here and then here. Okay. All I'm interested in is that you can do this part here for now. Okay. All right. So nice. That's it for our introduction into